In the solution to our lab exercise, we've created one activity application which will fulfill the listed requirements for this lab exercise. Let's start off by taking a look at our activity. We see that in our main activity, we do not call setContentView because we are extending our main activity from the list activity, and the list activity will take care of organizing our list of items for us. All we need to do is simply to call setAdapter with a new instance of the animation adapter which we have created for this solution. We have all of the logic, input callbacks, and asset loading for this solution done in our adapter. Let's take a look at our adapter now. Our animation adapter extends a base adapter, and we have declared a few constants in our adapter. The first being an array of animation resources in order that they should be displayed in our list. The second array is a list of string labels for each of these animations. We also have three members to this adapter, one for the sound pool, one for creating our bonus sound effects, one for an integer to store the sound ID for our rooster sound, which will play on each animation, and the last for a layout inflator for inflating the rows of our activity. Now let's take a look at the constructor for this class. In our constructor, we receive a layout inflator and we store it in our member variable. We then initialize our sound pool as we did in the audio example code, according to the version of Android to use the legacy initialization or the newer builder. Once the sound pool is initialized, we load our rooster sound file and store the sound ID. In our getCount method callback, we return the length of our array of animation resources. And in the getItem method callback, we return an integer for the resource at that position. Now in our getView callback, we inflate our convertView if it is not already inflated with the resource list item, which we'll take a look at in a second. We then set the text view in our view with the text from our label array. We also set an onClick listener to the button in our convertView to a new instance of anim button click listener. Let's take a look at the layout XML for the rows of this list before taking a look at the implementation of our new class, our anim button click listener. The layout for each row, as required in the instructions for this lab exercise, contain a button and a view to be used for our animation. In this case, we have utilized a text view for our animations, and we'll set a label for each animation to that text view. We put both of our elements within a horizontal linear layout. Now let's look back at our adapter and see the implementation of our onClick listener that we have attached to each button for each row of this list. When the onClick listener, a named button click listener, is created, it receives an integer for the animation resource ID and a text view to reference the text view to animate in its constructor. Then when the onClick callback of the listener is called, we play the sound from our sound pool and then we animate our text view. Notice that in the case of the animation set animation, we set the background to the animation as opposed to animating the view. This is because the animation set will not normally work on a text view, but will work on its background. So we can set to the background and then animate the background of this text view. Now let's take a look at some of the animations for these views. The animation set consists of a one-shot animation set of 7 simple PNG images that will each display for 400. Our enlarge animation will scale from 1 to scale 3 on X and Y and have a duration of 2000. Our fade in animation will fade from an alpha of 0 to an alpha of 1 with a duration of 2000. Our slide animation will slide from x delta of -50 to x delta of 50 using the accelerate interpolator and have a duration of 2000. Now let's run the application and see how it runs on the emulator. We see in our emulator the list of the 4 animations as required by this lab exercise. If we click the button for the fade in animation, we see the text fade in according to the alpha animation that we've declared in our XML. And we also hear the corresponding rooster sound when the button is pressed. In a similar fashion, when we click the slide animation and the enlarge animation, we see the animations that we've declared in our XML operate on the text views, as well as the sound associated with the on-click from our sound pool. Finally, when we click the button for the animation set, we see that the animation operates on the background of the text view. Thank you for joining us in this video with a solution to our lab exercise for the Graphics and Multimedia Lab.